There are more stars in the universe than grains of sand on every beach on Earth. Trillions of planets, billions of years of time for life to evolve, spread, and build civilizations. And yet, when we point our best telescopes into the dark, nothing. No signals, no megastructures, no evidence anyone else has ever existed. That silence has a name, and it's terrified physicists for over 70 years. In 1950, physicist Enrico Fermi was having lunch with colleagues at Los Alamos. The conversation drifted to aliens, UFOs, the odds of intelligent life existing elsewhere. Then Fermi asked a question so simple it stopped the table cold. Where is everybody? It wasn't a joke. Fermi had just done rough math in his head, and the numbers didn't add up. If intelligent life is even moderately common, the galaxy should already be full of it. Not might be, should be. Here's why. Our galaxy is roughly 13 billion years old. Even a civilization only slightly more advanced than us, with slow sublight speed spacecraft, could colonize the entire Milky Way in 5 to 50 million years. That sounds like a long time, but on a cosmic clock, it's nothing. A blink. If even one civilization had started spreading a few 100 million years before us, the galaxy should be saturated with evidence of them by now. In 1961, astronomer Frank Drake tried to put a number on the odds. He built an equation, now famous as the Drake equation, multiplying together the rate of star formation, the fraction of stars with planets, the fraction of those planets capable of supporting life, and so on, down to the likelihood of a civilization developing detectable technology. Depending on which numbers you plug in, the equation spits out anywhere from a handful of civilizations in our galaxy to literally millions. Millions. And we've detected exactly zero. So scientists started looking for reasons why. And the explanations that emerged got progressively more unsettling. The first is the Great Filter, a concept formalized by economist Robin Hanson in the 1990s. The idea is simple and brutal. Somewhere between lifeless chemistry and a galaxy-spanning civilization, there's a barrier that almost nothing gets past. Life might form easily. Multicellular life might be the hard part, or intelligence, or surviving your own technology once you invent it. And here's the part that should unsettle you. We don't know if humanity has already passed the Great Filter, or if it's still ahead of us. If the filter is behind us, if the jump from simple chemistry to complex life is the near impossible step, then we're rare, maybe even alone. And that's actually the comforting version of this theory. But if the filter is ahead of us, it means every civilization that reaches our current stage of development eventually hits something that wipes it out. Nuclear war, runaway climate collapse, engineered pathogens, artificial intelligence nobody could control. Something so reliably fatal that it has apparently stopped 100% of the civilizations that came before us every single time, without exception. We wouldn't know we were approaching a great filter. Neither would anyone else. That's what makes it a filter and not a warning sign. Then there's a darker proposal, popularized through science fiction, but taken seriously by some physicists, the dark forest hypothesis. It suggests the universe is silent, not because life is rare, but because it's dangerous to be loud. Any civilization broadcasting its location risks being detected by something more advanced and immediately eliminated, the way a rustling bush in a forest draws a predator's attention. Under this theory, every intelligent civilization eventually learns the same lesson. Go quiet or die. The silence isn't emptiness. It's civilizations hiding from each other. A gentler possibility is the zoo hypothesis. The idea that advanced civilizations know we're here and are deliberately leaving us alone, observing without interfering, the same way we might avoid disturbing an isolated tribe. Under this theory, the silence isn't absence. It's restraint. Scientists have tested pieces of these ideas directly. Since 1960, projects like SETI have scanned the sky for artificial radio signals. In 1977, an astronomer briefly detected a signal so unusual he wrote, "Wow," next to the printout, a burst of radio energy that matched no known natural source, lasting 72 seconds and never repeating despite decades of searching the same patch of sky. It remains unexplained. More recently, in 2015, astronomers noticed a star called KIC 8462852, nicknamed Tabby's star, dimming in strange, irregular patterns, unlike any known planet or dust cloud. For a moment, some scientists seriously entertained the possibility of an artificial megastructure. Follow-up observations eventually pointed to natural dust instead, but for a while the silence had cracked, just slightly. None of these leads has ever been confirmed. 70 years after Fermi's question, the sky is still quiet. Maybe that means we're rare, a fluke of chemistry in an otherwise sterile universe. Maybe it means something ahead of us is waiting, invisible and unavoidable, the same wall every civilization eventually hits. Or maybe it means the universe isn't empty at all, just old enough and wise enough to have learned that survival looks a lot like silence. Either way, next time you look up at a clear night sky, remember what you're actually looking at. Not proof that we're alone, just proof that, so far, nobody has said anything back.